1, 2, 3. We good? I think we are about to start. So yeah. We'll just wait for a couple of seconds. Yeah. I have my magic item here. Okay, now we can start. Okay, so hi everyone. This talk is titled Passwords Are Dead, Long-Lived Passwords. My name is Alejandro. You can find me on social media at Oviedo. I work on systems, generally Node.js. I'm also a GDE, a Google Developer Expert for the web. And I help co-organize a conference in Argentina. If you want the stickers, I have lots of them. Come and find me after the talk. So even though the talk was labeled as security talk, I consider it about the web and its users. For sure, security is a topic that will impact lots of different people out there, but it's mainly about the web. But before we can start about talking about the web, I wanted to do a recap on passwords, at least digital passwords. In the year 1962, I believe, there was a man that pioneered a system called compatible time-sharing system at the labs for MIT. And it's the man you can see on the image. On the room, it's a mainframe. And those round things, I don't know if you can see for the light, on the back, like old movie tapes, those are the storage system for the unit. And this had a lot of processing power back then, and students wanted to use its processing power. And so the requirement was have a terminal for each student or researcher and a set of permissions on files for each one of them. So that's why they implemented this system. This man is Fernando Corvado. And it's believed the first time a password was implemented. Later on, we can talk about how it didn't work back then. A student asked for a file to be printed. And turns out he asked the system to print the file where passwords was being stored. So later on, the next day, he went to the print station and he got a physical list of the passwords in the system in order for him to use more processing power on the mainframe. So in the 1970s, this man on the picture, Robert Morris Sr., helped create the Unix operating system. And he was also the pioneer for what we know as hashing for passwords when we store them. If you want to know a really interesting story, ask me about his son on the hallway. In the year 1985, the Department of Defense had this document as a guideline for pretty much computer system and password management as well. And for that time, it introduced a lot of interesting mathematics around password security. But it also had a couple of items listed as statements For example, that the security of a password is diminished over time, or that a password should have an expiration date. And all of those things were stated in this document without any analysis whatsoever. But it was something. It was a good starting point. We will talk about the year 2000 because I couldn't find any information whatsoever on the year, or at least the decade 1990. If you know about something that happened related to passwords, I will be happy to add that to the timeline. So around the year 2000, there was research taking place to take over passwords. And don't get me wrong, I think it's essential for progress for this type of research to take place. And I'm not arguing about its security perspective, but I will talk about the user approach for this idea. It's not user-friendly, and it's not, and maybe for accessibility, people that have motion restrictions could be also a problem, and turns out it didn't stick. In the year 2003, there was a document that was also published and by the NIST. Maybe from the name, you cannot tell about what it is. It was an unfortunate name. But it's also about password management and password security. And it will be the cornerstone for the next decade and a half in terms of password security. It introduced a lot of new concepts and also a couple of statements without further analysis. For example, one of those statements was that passwords should have also an expiration date. And generally speaking, the document has lots of level of security, but it generalized as 90 days for the period of a password. The special characters we are used to heard about in a password, camel case, lowercase, numbers as well, they all come from this document and the guidelines that it introduced. 15 years later, the author of this document, he publicly mentioned that he regrets making a couple of those statements and that it doesn't make a password more secure, generally speaking. In the year 2004, Bill Gates predicted the end of the password. He predicted that because around the year 2003, there was a second two-factor authentication device called Secure ID, taking a lot of popularity, and it was very well known in different circles. But it was only about Windows. It didn't work well with the web, and moreover, it didn't work well with mobile devices. So Gates said, passwords just don't meet the challenge for anything you really want to secure. I can really agree with Bill here. There's a famous comic, XKCD, where he depicts the irony of the password and the best practices for passwords, and how a password that follows the best practices is easy to guess for a computer, but very hard to remember. Where a passphrase for different words for random words that doesn't follow the best practices could be, in theory, better for security. At the bottom, I don't know if you can see it, it says, through 20 years of effort, we have successfully trained everyone to use passwords that are hard for humans to remember, but easy for computers to guess. And I love the author of the comic. Its content is really good. But I think in here he captures something, but he doesn't argue about the status quo of the problem. Why a person's memory has to be involved for a service or for an application to be secure. In the year 2011, there was also some research going on to leave passwords once for all. I can really relate to the title, anything but a password. I can't remember the year of this video. It didn't took off eventually, and it wasn't for sure one of the first ideas to implement biometrics for authentication. But it was a good idea to have authentication on your wearable. But turns out it wasn't really integrated with the web as well. It could work well with native desktop apps and maybe native mobile apps. But there was also nothing certain about how the authentication would take place. Would the information go to a server, and the server would use that to authenticate me? In that case, if the server is compromised, then everyone would know how my heartbeat looks like. And that's for sure a privacy concern. Okay, let's do a show of hands. How many here use a password manager? Okay, for those who are not in the room, maybe 90%, 80% of the people is using a password manager. This was a white paper published in the year 2017, and it's titled An Investigation into Users' Considerations Towards Using Password Managers. I would really recommend the publication if you are into the topic. And I grabbed a little quote for its conclusions. More users, password manager users, than non-users in our sample report higher technical expertise, especially in the area of computer security, which could reflect an actual higher technical proficiency among users. And we all failed to improve this. We failed as developers, we failed as businesses, we failed as users for demanding a better user experience, a more straightforward process. And we all lost for that. There are accounts being breached consistently. Every day we learned about a breach in a service, in an application, in a system. So yeah. And we can see the effects on our surroundings. There was a book that I found on a library, helps you with your memory. Apparently, it's also helping to memorize all your passwords. This was also something that person found and sent the photo to me. It's a sticker to keep all your passwords maybe written down on your drawer. I have no idea. But yeah, this is real. And yeah, we don't want to spend much more time on that because it's really sad. I wanted to talk about what we can do to change that and how I think things are going to be better. Could you imagine a world without passwords? I certainly can, and I think it looks like this. So the idea behind that world, there's a couple of standards. The name is FIDO, which congregates or groups two different standards. On one side, the Web Authentication API. On the other side, the client to Authenticator protocol. So the Web Authentication API is the part that your browser is implementing to get information from devices. Authenticators like this, so that the developer or the team that is working on the website doesn't have to focus on how to get the information, but rather use an API. For the other standard, the client to Authenticator protocol, it will specify how the data is being sent from the device to either the operating system, to the browser, to actually anything that wants to integrate to that protocol. And it also specifies the types of properties that you can send and the types of methods that you can call on each of these devices. So let's talk about a little bit about this. And within the FIDO standard, there's two ways that are recommended or specified. On one side is the Universal Authentication Framework, which would replace passwords once for all. And on the other side is Universal Second Factor of Authentication, which would be used with passwords as a second factor. And that could mean devices that are connected through USB, through NFC, through Bluetooth device. There are a couple of options out there for authenticators. So let's talk about how process is being done through this standard. So there's two actual ways of doing this. The first one would be the registration, in which you have a key with you, an authenticator, and you want to register that into the service or the website. And the other one is where you want to log into that website. So for registration, there are a couple of steps. The first one is the client, that could be the website or any other client, requests a challenge for a specific user. The server sends that challenge. We'll talk about the challenge and the third one is the client uses the Web Authentication API to get the information from the device to the browser, and uses the keys that are created on the device to send that to the server. And the server will say, hey, your registration was successful or not, maybe. So next, once you have the device or the key registered, you can log in using that. The client requests a challenge for the user. It's pretty much the same as the first part. The server sends a challenge. The client uses the API, the Web Authentication API, to sign the challenge. There are no credentials created, but just those credentials that were created on the first step will be used to sign the challenge. And the client sends back the the result of the call. And the server will identify if the process was successful or not. We will talk about that just in the demo. Okay. Have a couple of minutes. So I have my server running here. I will log out and close this. So you won't be able to see it, but I have one of these keys plugged into my laptop, and it will show a flashing LED requesting for user presence. That's important to notice. Otherwise, the process or the browser won't be able to authenticate or register. So we will use oh wait, we haven't registered. So I clicked on register. It was a lazy thing for me to do to add to this demo. But right now, the browser requested presence for my key. Now, if I touch the key, it will pop up something saying the website is requesting to see the model of your security key. You can block it or you can allow it. It's important for the server to have information about the key so that it can verify the manufacturer of the key. Say you were expecting a key from a certain manufacturer. The information that you send to the server is the only way for the server to verify for that key to be authentic. So now we are logged in. Let's do the process of logging instead. Now my Authenticator LED is flashing again. It will ask me for, oh, it didn't ask this time. And we are logged in. We have a couple of minutes to show how this is done on the backend side. We will start our server with the debugged, and we will register a different one. Yes. Oh, wait. I want to debug on the front-end side as well. Okay, so now we can see some code. It stopped right before the call get make credential challenge. And as you can tell from the name, it will ask for the challenge. That will be a request to the server. Let's do that and step into the server. This is the server code. As you can see, this is an example using Express and a couple of routes, one for registration and one for the login part. We're just before the call to generate server make credential request. And that's kind of where the magic happens. I won't dive into details for the cryptography part because maybe that's not so interesting. But let's see what it returns. And we can see that there are a couple of properties within the response. There's one called attestation, and that's the information you have within each of these authenticators. The server is requesting the direct type. So it's actually saying to the browser, hey, send me the information that you have on the device because it's important. The server can change that, of course, and can also, the client can refuse to send that data. It's the job of the server to define whether the server wants to accept anonymized data or not. Okay, let's continue. It's setting the session and then responding JSON information. Nothing too fancy. So RP property stands for relying party. It's another way of calling the server. If you read the spec, that's the way the spec calls the server. There's also a public key type of algorithm specified, user ID that is generated and encoded automatically, and the challenge. So it's important for the process to be secure, for the challenge to be created on the backend side of the application. And it's also essential to the security of the process to have the challenge be randomly generated. Okay, let's continue. And we are now on the front-end side. We are, excuse me, we have now the response, and we are ready to send that information to the Web Authentication API in the line 56. And what it will do is it will halt the execution until it returns a response from the API. And that will happen once the user verifies the presence. So if I touch in here, the browser will ask if I want to allow that. I want. And then the next thing will be grab the response for the API and send it to the server once again. We are now on the backend side, and we can see that there's a route for a response. It's the same one for registration and for logging. And within here, we are just before this if statement. On the first part will be a registration. If this is not present, then it will be logging. In this case, we want to step right into. So again, within this method is where all the magic happens for cryptographically secure algorithm, and we have the response from the device in here, in this object. We'll have the attestation object, client data, JSON, raw ID, some other fields. And the result for that method is information about the type of authentication these devices enabled for FIDO, U2F, and the public key for that. So if it's verified, then it will then save that to the database as a registered information. So now we are registered. Let's go to the logging. We have a couple more minutes. So the logging. We are right before the get assertion challenge. which again will be from the backend, and we are sending the username. Oh wait, it was the previous username. Doesn't matter. If we step right into that, yeah, we didn't want that user. Okay. We are now in the backend, in the logging route, and we can see that it's sending information about the username, and again, within this util method will happen the verification, and we'll create the challenge that we can see for the username in here. And the server is sending that it supports devices that are connected through USB, NFC, or Bluetooth, low energy devices as well. We are now back on the front end. We just got the challenge from the backend. We are ready to get to call Navigator credentials.get, which will ask for the device to sign the challenge and return a response. If we step right into that, again, it will hold until the user presence is detected. So if I touch the authenticator, will return the value from the API. And we can see information about the response and the ID, the type of the algorithm as well. And here, we can see that it's sending back the information to the server. And it will go to the second part of our backend in here, which is specifying that there's a logging attempt. And we'll have Authenticator data in the response. With that and the whole information about the registered user, it will then verify that it's a valid user logging, and it will return verified. And we can see that on the front end, we are now logged in. Okay. So a simple diagram of what we just tested and showed in here. So on the top left, you can see the FIDO authenticator is this one, the one I'm using. The attestation key is the information about the manufacturer. It's sending the attestation object. The server in here is a FIDO-enabled server. It will verify the attestation, the information from the key. And the server can reach out to a metadata service, which has the information from the vendor. The vendor is supposed to be providing certificates to verify the authenticity of the device. So a new standard, or at least a new version of the standard, was released this year, which is FIDO 2, and basically presents pretty much the same flow. It redefines the names for some things. the Web Authentication API is still the same. The client to Authenticator protocol changed, and it's now the version 2. So what changed? It allows to now called single-factor authentication, second-factor authentication, or a multi-factor authentication all in once, and use that with or without passwords. Instead of, for the first version of FIDO, it will go with biometric information just for single factor, and for second factor authentication, we'll still rely on passwords. So thus, this means passwords will be no more used on the web or on systems. It's really hard to tell, and I don't think it's a question we are able to respond now. It will depend on the adoption rate of the API, the adoption rate of the devices, at least for desktop. There are other options that an operating system can integrate with this standard. And for mobile devices, there's an option of using NFC-enabled authenticators, or to use your biometric information such as fingerprints. But not all the mobile devices out there have that type of integration. So it really depends on lots of factors out there. And we will need time to see what happens. It will certainly take time for a new technology to be adopted. Thank you all for listening. You can find the slides and the links to the demo, the links to the published articles, and all the things that I showed today here on that link. Yeah, and that's it. Thank you very much.